Welcome to our online chemistry class. Our topic is coordination compound. Here we'll discuss IUPAC nomenclature of coordination compound. So there are some rules for naming the coordination compounds recommended by IUPAC, and they are as follows. So first rule is, in naming the complex ion or neutral molecule, the name the ligand first and then metal ion. For example, CuNH3 4 time 2 plus, so it is a complex ion. First you have to write the name of ligand. Here ligand is NH3 and they are 4 in number, so 4 number can be denoted by tetra. NH3 can be denoted by amine, so tetraamine, and then the metal copper is mentioned. Okay, and second rule is, the name of anionic ligands are obtained by changing the ending IDE to O. So for example, Br minus, that is bromide, IDE can be written as bromo, IDE replaced by O, and the ATE by ATO. So C2O4 1 minus, that is oxalate ligand, the ending ATE replaced by ATO. Then third rule is, the name of a complex is one single word. So here tetramine copper single word is used, tetramine dichloroplatinum is the single word, and there must not be any space between different ligands name as well as between ligand name and the name of metal. So after ligand word, the metal is also written with single word. Then fourth rule is, after the name of metal, write its oxidation state in Roman number. So here oxidation state of copper is 2 plus, because overall charge is 2 plus. Ammonia is neutral ligand. So what is the oxidation state of copper in this complex? It is 2. So it is denoted by 2 number in Roman. In this case, Cl is 1 minus, there are 2 chlorine, so 2 Cl carrying 2 minus charge, and ammonia NH3 is neutral in nature, so Pt carrying X minus 2 is equal to plus 2, so Pt carrying plus 4 charge, that is plus 4 oxidation state. So in the name 4 is written in Roman, so that is written in round bracket parenthesis without any space between the metal name and that round bracket. Okay, so continue is written. Fifth rule is, if complex has more than one ligand of the same type, the number is indicated with prefixes di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, and so on. So if you observe the first compound, there are 4 ammonia molecule, so tetra word is used. Here also tetra word is used. There are 2 chlorine, so di for 2. Then sixth rule is, for the complex having more than one type of ligands, they are written in an alphabetical order. Suppose 2 ligands with prefixes are tetraaco and dichloro. So here the T for tetra and D for di is not considered, but ligand name A for aqua and C for chloro is considered, and they are written in alphabetical order. So tetraaco is first because A is alphabetically first than C in dichloro. So in this way you have to arrange them. Then seventh rule is, if the name of ligand itself contain numerical prefix, then The display number by prefixes with bis for 2, tris for 3, tetrakis for 4, and so on. And put the ligand name in the round bracket. For example, ethylene diamine is the ligand. Ethylene diamine is the ligand and it is 3 times. So it is shortly denoted by En3 and it would appear as, so 3 number is there for that ligand, so tris word is used, so it is denoted by tris ethylene diamine and not tri, or it is also called as tris ethane 1 comma 2 diamine. Then last rule is the metal in cationic or neutral complex is specified by its usual name, while in the anionic complex the name of metal end with ATE. So for example, FeCN6 4 minus, it is anionic ligand, anionic complex, and there are 6 CN ligand, CN cyno, so hexa means 6 hexa cyno, then CN carrying 1 minus charge, so 6 CN carrying 6 minus, so 6 minus, and overall charge on the ligand is minus 4, so x minus 6 is equal to minus 4, so x carrying plus 2 charge. So what is the oxidation number or oxidation state of Fe? It is 2, so 2 is written in round bracket. Then name of the metal ends with At, so iron can be denoted by ferrous, so ferrite with its oxidation state in the round bracket. So you can try this at home and give the structure for following names in my comment box. Okay, now so again some IUPAC names of anionic and neutral ligands are given in this table. So Br minus bromide, so IDE replaced by O. So this is the second rule. Chloride, Cl minus chloride chloro, fluoride fluoro, iodide iodo, cyanide cyano, sulfate sulfato, nitrate nitrato. So here printing mistake, it is nitrate, TRATE, so nitrato. These are negative ligands. Then the CO32 minus carbonate carbonato, OH minus hydroxide hydroxo, then C2O4 1 minus oxalate, replace ATE by ATO oxalato, NO2 1 minus nitrite nitro, and here nitrogen is used as a bonding site. ONO, it is also a nitrite, but and it is nitrito because here oxygen is bonded site. Then HCN minus thiocyanate thiocyanato, NCN minus thiocyanate, so it is written as isothiocyanato. Here donor atom is nitrogen, and in previous case donor atom is thiocyanato, donor atom is sulfur. Then neutral ligand NH3 ammonia is the normal name. What is the IUPAC name used? Amine. Spelling check the spelling, AMMINE. CO carbon monoxide carbonyl, water H2O, aqua, En ethylene diamine, and use the single word, there is no space. Then IUPAC names of metal in anionic complex. Aluminium, replace the word IUM, aluminate. Then cobalt, cobaltate. Gold, the Greek word is orium, orate. Manganese, Mn, magnate. Platinum, platinate. Then chromium, chromate. Copper, cuprate. Iron, ferrous, ferrate. Nickel, nickelate. Zinc, zincate. So first type is anionic complex, means it is negative complex. First compound is NiCN4 2 minus. So first of all we will calculate the oxidation state of nickel. So there are four cyano groups, cyanide ions are there, which acts as a ligand. So and each carrying 1 minus charge. So oxidation number of nickel is X plus 4 into oxidation number, or the charge on that CN is 1 minus, overall charge is minus 2. So X is equal to plus 2, which is the oxidation state of nickel, and it is written in round bracket. There are 4 CN, so tetra word is used, tetra cyano. As it is anionic complex, nickel become nickelate. And lastly you have to write the word ion. So tetra cyano nickelate 2 ion is the correct IUPAC name of first compound. Then B is CO C2O4 thrice 3 minus. So C2O4 is 2 minus. So oxidation number of, or oxidation state of CO is X plus 3 into minus 2, and overall charge is minus 3. So is equal to minus 3. So X is equal to plus 3. So it is written in round bracket. There are 3 C2O4. So trioxylato, and cobalt is written as cobaltate because it is anionic complex. And last word ion. So name is trioxylato cobaltate 3 ion. Then next complex is FeCN6 4 minus. So oxidation state of Fe is X, Cn is cyanide 1 minus charge. So 6 into 1 minus is equal to charge on the anionic complex is minus 4. So X minus 6 is equal to minus 4, X is equal to plus 2. So which is the oxidation state of your Fe. And there are 6 Cn, so hexacyano ion can be written as ferrate. And lastly iron word is there. So correct name is hexacyanoferrate 2 ion. Now next type is compounds containing complex anion and metal cation. So only the change in the first and second type is, instead of this overall charge which is negatively charged, it is balanced with some positive metal cation. So here Na3CO NO2 6 times. So now we have to calculate the oxidation number of cobalt, which is written as X. There are 3 sodium and each sodium carrying 1 plus charge. So 3 into 1 plus X is the oxidation state of cobalt. Then NO2 carrying minus 1 charge. So 6 times 1 minus, and overall compound is neutral. So is equal to 0. So X is equal to plus 3, which is the oxidation state of your cobalt. So first write down the name which is written outside the square bracket, which is sodium. There are 6 nitro groups, so hexanitro, and cobalt become cobaltate as per your previous name, cobalt, cobaltate. Don't write the ion after the ending of your name. Then K3Al C2O4 thrice, K carrying 1 plus charge, C2O4 carrying 2 minus charge. So 3 into 1 plus oxidation state of aluminum is X plus 3 into charge on C2O4 minus is 2 minus, overall compound is neutral, is equal to 0. So X is equal to plus 3, which is written in bracket for aluminum. Potassium is outside, don't write tri potassium, only write down potassium. There are 3 oxalates, so trioxylato aluminum oxidation state is 3. Okay, then Na3AlF6. Now you have to calculate oxidation number of Al. Oxidation state of Na is plus 1, so 3 into 1 plus, for Al is X, for 1 fluorine minus 1, 6 fluorine is 6 into minus 1. overall charge is 0. So what is X? X is equal to plus 3. So how do you write the name? First is sodium, then there are 6 fluorine, so hexafluoro, aluminum become aluminate, and write down the oxidation state as a 3. So sodium hexafluoroaluminate is the name of this compound. Now next type is cationic complex. Now the overall charge is plus, so that's why name is cationic complex. So their names are different than anionic complex and compounds containing complex anion and metal cation. So don't write word AT after the name of your central metal element. Okay, so CuNH3 4 times 2 plus. So you have to calculate oxidation number of Cu. It is X. Ammonia is neutral, so 4 into 0, and overall charge is plus 2, so is equal to plus 2. So X is equal to plus 2. There are 4 ammonia molecule. So tetraamine, write down copper word as it is for the element, which is the central metal atom. Oxidation state is 2, and write down the word ion. Don't write cuprate. Okay, don't write down AT at the end. Then FeH2O5 times NCNCS. So write down oxidation state of Fe as X. Water, it is neutral, so 5 into 0. NCS means thiocyanate ion, and each carrying 1 minus charge. So X plus 5 into 0 plus minus 1 for NCS, and overall charge is plus 2. So what is the oxidation state? It is plus 3, which is written in round bracket. There are 5 H2 molecules, so write down penta aqua. Then here NCS is the, that is thiocyanate, but it can be written as isothiocyanate, isothiocyanate, and Fe iron. Okay, so iron, and oxidation state is 3. So PtEn twice SCNS twice 2 plus. So oxidation state of Pt is X plus 2 into ethylene diamine is neutral, so 0 is the charge. Then SCN is thiocyanate ion. Here donor atom is sulfur. In previous case, donor atom is nitrogen. Both are thiocyanate, but their names while writing the IUPAC name is different. What is the charge? 1 minus. So 2 into minus 1, and overall charge is plus 2. So X is equal to plus 4, which is written in round bracket for oxidation state of platinum in Roman word. So there are 2 ethylene diamine, so use the word bis. Okay, because diode is used in ethylene diamine as a name of ligand. Then 2 SCNS. Now donor is sulfur, so thiocyanate word is used, and they are 2 in number, so dithiocyanate. In case of previous, N is the donor atom, so isothiocyanate. Remember this difference. Then platinum 4. Then compounds containing complex cation and anion. The first compound is so here PtBr2 NH3 4 times Br2. So oxidation state of Pt is X plus 2 into charge on Br is minus 1 plus 4 into NH3 is neutral, so 0. Then there are 2 bromine, each bromine carrying minus 1 charge, so minus 2, and overall charge is neutral compound, so 0. So X is equal to 4, which is the oxidation state of platinum, written in round bracket in Roman number. There are 4 ammonia molecules, so tetraamine, 2 Br, so dibromo, platinum word is as it is, and at the end the ion which is written outside the bracket, which is, even though they are two in number, use the word bromide as it is not right, dibromide. Okay. The next one is CO NH3 5 times CO3 Cl. Oxidation state of cobalt is X, NH3 is neutral, so pi into 0, CO3 is 2 minus, so minus 2, 1 chlorine is outside the bracket, so minus 1, overall compound is neutral, so is equal to 0. So X is equal to plus 3, written in round bracket as a Roman number. So there are 5 ammonia molecules, so pentamine, then 1 carbonate, write down carbon atom, cobalt as it is, write down the oxidation state 3, and outside the bracket chlorine is there, so chloride. Then CO H2O NH3 5 times I3. So oxidation state of CO is X plus oxidation state of H2O, there is no charge, so 0. Then NH3 is also neutral, so 5 into 0 plus outside 3 iodine, so each carrying minus 1 charge, so minus 3, and overall charge compound is neutral, so is equal to 0. So X is equal to plus 3, which is the oxidation state of cobalt, written in round bracket in normal number. So there are 5 ammonia, so pentamine, 1 water, aqua. So after A, M is in amine and Q in aqua, so write down amine first. Aqua, cobalt as it is, write down oxidation state and followed by the word iodide. Don't write triiodide. Okay. A neutral complex, CO NO2 thrice, NH3 thrice. So oxidation state of cobalt is X plus 3 into charge on nitrate is minus 1 plus 3 into ammonia is neutral, so 0 is equal to 0. So X is equal to plus 3, write down in bracket. So it is neutral compound. So there are 3 NO2 groups, so trinitro, but amine is there, so A is alphabetically first, so triamine, trinitro, cobalt 3. Okay. Then FeCO 5 times X plus 5 into 0 is equal to 0 because CO is neutral. X is equal to 0, so write down in round bracket 0. There are 5 carbonyl groups, so pentacarbonyl ion, word as it is, and write down oxidation state of ion as 0. Then RH NH3 thrice, SCN thrice. So what is the oxidation state of RH? X plus 3 into 0 because NH3 is neutral. SCN is minus 1, so 3 into minus 1 is equal to 0. So X is equal to plus 3, write down in bracket. So there are 3 ammonia molecules, triamine, 3 SCN. So sulfur is the donor atom, so thiocyanato, and there are 3 numbers, so trithiocyanato. RH means rhodium, write down oxidation state.